So we just discussed about the basic concepts related to dot product. Okay, how dot product is expressed, what is the meaning of dot product. So when we say dot product, what exactly are we trying to tell, to express? So in this video we are going to discuss some important properties of dot products. Okay, so we'll be discussing properties of dot product. So we have discussed that dot product of two vectors, A vector, B vector, with an angle theta between the point where the tails meet, is expressed as this: A B cos theta. Okay, or it is also written as A vector magnitude, B vector magnitude or modulus, and cos theta. This. So here this cos theta part is very important. Okay, cos theta or theta, it is very important. Okay, so we'll discuss the various values of these dot product when the value of theta changes. Let's say theta is equal to 0 degree. So this is the situation where both the vectors A vector and B vector they are in the same direction. Okay, when they are in the same direction. So in this case the dot product of the two vectors will be A B cos 0 degree. Cos 0 degree is 1, so it will be simply A B, or A vector modulus multiplied with simple multiplication with B vector modulus. So this is when theta is equal to 0 degree, both A vector and B vector they are in the same direction. Okay, then we have another case when theta is equal to 180 degree. So this is the situation where the vectors are in the opposite direction. The vectors are in the opposite direction. Theta is equal to 180 degree. So here in this case the dot product is A vector dot B vector, A B cos 180 degree. Cos 180 degree is minus 1, so it will be simply minus AB, or it will be equal to minus A vector modulus B vector modulus. This. Okay, minus AB. Then the third case, when theta is equal to 90 degree, or the 270 degree case. So here the vectors A vector and B vector they are at right angles. Okay, they are at right angles with respect to each other. So here A vector dot B vector, it will be AB cos 90 degree. Now we know cos 90 degree is equal to 0, so it will be AB multiplied with 0, the result will be 0. So in this case, where the vectors are at right angles with respect to each other, the dot product of the two vectors will be 0. Same is the case when angle is 270 degree, because it's the same thing. So this is the different values of dot product for different values of theta. Okay, so this is let's call it the first property related to dot product. Then another important property, sorry, so let's call it the second property. Now we just discussed previously that dot product is expressed as the magnitude of a particular vector multiplied with the scalar projection of the second vector with respect to the first vector in the direction of the first vector. We can write it as this: A multiplied with B cos theta, which is the first vector A vector magnitude multiplied with the scalar projection of the second vector, that is B vector, along the direction of A, which is B cos theta. Or it can be written as B, considering it the first vector, and then the scalar projection of A vector along the direction of B vector. So both ways it is the same. We can write it as AB cos theta. It is also same as BA cos theta. Okay, so this is B vector dot A vector, this is A vector dot B vector. So both ways, whether we perform A vector dot B vector or B vector dot A vector, we are getting the same result. Why? Because A, B, cos theta, they are all scalars. Okay, so whether we do A, B or B, A, they all mean the same thing. So from this we understand that A vector dot B vector is the same as B vector dot A vector, or we can say that the dot product or scalar product, it obeys commutative law. It obeys commutative law. This. So the order in which we multiply, we try to find out the dot product, it does not affect the result, the final result. Okay, only for dot product. Okay, for vector product or cross product it will be different. Let's not bring that here. So only for dot product, the order in which we put the vectors, that does not affect the result. Okay, this is the second property. Then we have the third property, which is that, let us say we do A vector dot B vector plus C vector, okay, like this: A vector dot B vector plus C vector. So here it can be written as A vector dot B vector plus A vector dot C vector, like this. Okay, like this. So what we are trying to say is that the dot product or scalar product, okay, the dot product or scalar product, it obeys distributive law, the law of distributive law. That. This is the third important property related to dot products. Okay, so this is the first, this is the second, this is the third. So another important property which we'll discuss here is, suppose we take a vector, let's say a vector, and we try to find out the dot product of this vector with itself. Okay, with itself. Now both vectors are a vector, they are of same magnitude and they are in the same direction, that is theta is equal to 0 degree. So it can be written as a vector modulus multiplied with a vector modulus again cos 0 degree, which is a into 1, which is equal to a square. So what it says, that the dot product of a vector with itself gives square of the magnitude of that vector. Okay, this a vector dot a vector, it gives us the square of the magnitude of a vector. That is the fourth important property related to dot products. Okay, so we have discussed about the commutative and distributive nature of dot product. Dot product obeys commutative and distributive law. So next we'll discuss about another important property of dot product. Okay, so let's say a vector is multiplied with a scalar quantity, let's say m, and another vector b vector is multiplied with another scalar quantity n. So now the dot product of these two vectors, okay, scalar quantity which is multiplied with a vector and the scalar quantity which is multiplied with b vector, that will give us m n then a vector dot b vector. So m and n, the scalar quantities, they go outside, then the dot product takes place as usual, and mn, they get multiplied as scalar values outside. So this is another important property of dot product. Okay, so this is called as the associative property or associative law. It obeys associative law. Okay, so here we have discussed some important properties related to dot products. Okay, starting from here, the how theta impacts the value of the dot product, then the dot product with respect to commutative law, distributive law. Dot product obeys both commutative and distributive law, and then the dot product of a vector with itself, which gives us square of the magnitude of the same vector. Okay.